Okay, here's another equation to solve. This time we won't generalize it. We'll just find the solutions between 0 and 2 pi. And 2 pi is not included while 0 is in the interval that's stated. The equation is tangent squared x sine of x equals sine of x. Now, I'm going to take you back to your algebra roots because everyone's tempted right here to try to cancel the guy from each side that's alike. But you cannot, in algebra, cancel terms with variables in this manner, or you lose potential solutions. So what you would have to do is move everything to one side and then take out the variable common factor and go from there. Okay? So the same thing is true here. While it's tempting to want to cancel the sine of x, it's actually incorrect to do so. So I will write tangent of x sine of x minus sine of x equals 0. We'll factor out the common term sine of x, which leaves me with tangent squared x minus 1. And now I see from the fundamental theorem of algebra that I have two possibilities. Sine of x equals 0 or tan squared x minus 1 equals 0. Okay, well, let's deal with sine being 0 first. In the interval that's half closed, half open, 0 to 2 pi, sine is 0 at 0 and pi, while sine is also 0 at 2 pi. 2 pi is not included in our choices, so we must stop here. Okay? All right, now tangent squared minus 1 equals 0. I showed you earlier that if you have a square term that you can legitimately isolate, no other variable terms, then you can use the square root property and take the square root of each side. And in this case, we get that we want where tangent of x equals either plus or minus 1. We need a reference angle, so therefore we need a reference triangle. And the one triangle that we know that's very nice, that demonstrates for us when tangent is 1, is the 45-45-90 triangle. Tangent of an acute angle is the opposite over the adjacent. We get a value of 1. And because we want where tangent's both positive as well as negative in one full rotation, we're going to list the angles all 4 quadrants, okay? In all 4 quadrants, rather. So the first solution would be pi over 4. The second solution is pi minus the reference. That's the second quadrant. Common denominator gives you 3 pi over 4, although Webasine has no problem accepting pi minus pi over 4. Third quadrant is pi plus your reference. And the fourth quadrant is 2 pi minus the reference. And again, if the calc pad pops up, you don't have any reason to need to simplify anything. You can just type these as is. So we have basically quite a little list here between 0 and 2 pi. And there was nothing in the problem that said you had to enter them in any particular order. So we'll just make a comma separated list. And we're good to go. And again, if you wanted to write these in the unsimplified form I underlined, you certainly could. And again, so the big reminder here is that it is a boo-boo if you cancel a variable term from each side of an equation. That's an algebra boo-boo. So move it over and factor and then go from there.